In today's video, we'll be talking about nuclear physics. After watching this video, you should be able to understand what a subatomic particle is and how it makes up the nucleus. Understand the difference between an alpha particle, a beta particle, a positron, and a gamma particle. And then the biggie is that you need to be able to calculate or balance a nuclear equation, which if you've done any balancing equations in chemistry, won't be that big of a deal. So let's get right into it. Just a quick review on some concepts that we have seen already in class. Protons and neutrons are found in the center of the nucleus. Remember, protons are positively charged and neutrons are neutral. And protons have a charge of 1.6 times 10, and this is supposed to be to the negative 19th coulombs of charge. Okay, so it's a very small amount of charge. Sometimes people, because it's such a, like this number is kind of icky to write, sometimes people just call it one elementary charge, or 1e, so plus 1e. Whereas the opposite of a proton, having an equal amount of charge, is the electron. And electrons are negative. That's supposed to be a negative sign. And they are found outside the nucleus. They are orbiting around the nucleus. And electrons have a charge of negative 1.6 times 10 to the negative 19th coulombs of charge. And again, because that number is kind of icky to say, sometimes they'll call it the elementary charge, and they'll call it negative 1 e for its charge. Okay, and that's all stuff that we talked about when we were talking about static electricity. Now, the mass of the proton and the neutron are about equal. In total, if you're curious, they have a mass of about 1 times 10 to the negative 27th kilograms. So a very small amount of mass, but the majority of the mass in an atom is from the proton and the neutron. And this is sometimes referred to as U, or an atomic mass unit, AMU for short. So 1 U is 1 times 10 to the negative 27th kilograms. A neutron is about 1 U also. Okay, it's not exact, but for our purposes, we don't really need to worry about the neutron, so it's about 1 U. What's interesting is the electron is about 1,800 times smaller in mass than the proton. Right, so it is considerably less. And if you're curious, the mass of one electron is 9 times 10 to the negative 31st kilograms. So generally, we assume that electrons are massless. Even though they're really not, we make the assumption that they are, compared to the proton and the neutron, they basically are massless. The electron cloud is an area of space around the atom, and basically this is where the electrons can be found. The electron cloud takes up the majority of the atom. The nucleus, where the proton and the neutron can be found, is extremely dense, but very small. And the reason why it's so dense is because it accounts for most of the mass. You have this tightly bound area with a bunch of mass, and then the rest of it's kind of this electron cloud that's just orbiting around the nucleus. So we're going to talk about some kind of ways of describing the nucleus of an atom, and this may seem somewhat familiar to you if you've taken chemistry. If you haven't, don't worry, we'll go through it. This on the right is kind of the standard model of this E stands for helium. Okay, and these numbers all have they mean something. Okay, so this 2 is referred to the atomic number, and this is the number of protons found in helium. Okay, so helium has 2 protons. And remember, protons are positive. This top number is called the mass number up here, and this is basically the number of protons plus the number of neutrons. And so if you add those two together, you get 4 AMU. So you'd have 4 AMU because you have 2 protons and 2 neutrons. And remember, protons and neutrons are what primarily make up the mass of an atom. Electrons basically don't have any mass for our case. Okay. Now in physics, we do things a little bit differently, especially in nuclear physics. You typically will see things like this, where you have an X, which X stands for basically any element, any unknown element on the periodic table. Z is the atomic number, and I have that written here what Z is. The atomic number is the number of protons. And this is maybe a better way of looking at it is the actual charge on the nucleus. Okay, so for instance, helium has a charge of plus 2 protons in the nucleus, okay, plus 2 charge. Remember, charge is E. That is the elementary unit of charge. Now, if we want to figure that out in coulombs, we could take the number of protons times 1.6 times 10 to the negative 19 to figure out a charge in coulombs. But for the most part, we just call it like the elementary charge. So helium has a charge of 2 plus 2 in the nucleus. Okay, now if it has 2 electrons to counteract those 2 protons, then it's neutral. Okay, but typically we won't be seeing that when we're talking about nuclear physics. Typically, things will be they will have a large amount of charge, either positive or negative, one way or another. Sometimes they'll have all protons and no electrons even in the nucleus. I'm sorry, on the atom. And so the charge is quite a bit in terms of the positive or negative direction. Okay. Now, one little quick side note here. On the periodic table, the mass number is given as an average because there's these things called isotopes. Like there's carbon 12, carbon 13, carbon 14. Basically, an isotope is an atom that still has the same amount of protons, but it has a different amount of neutrons. And so the mass is a little bit different. I kind of look at it like twins, that carbon has a variety of twins that are similar to it. The periodic table takes the average of those numbers and gives you an average mass number. In physics, we don't really want to deal with that. We want to deal with just a solid number. And so we call this the mass number, and this is the number of protons plus the number of neutrons. So if we're dealing with, say, carbon 14, for instance, carbon is atomic number 6 in the periodic table. So it has 6 protons, and if you take 14 minus 6, that would give you 8 neutrons would be found in carbon 14. Okay, so just kind of keep that straight because I know it's a little bit different than chemistry where the atomic number, the mass number on elements in the periodic table will be like 12.06 or something like that. And that's basically an average of the isotopes that are found in nature. So here's just some examples. Okay, remember this is the atomic number and this is the mass number. How many neutrons does the above hydrogen have? Okay, how many neutrons does the above hydrogen have? Well, this number right here is telling us the number of protons. And so if it has 1 proton, okay, this one here must mean that all of the mass in hydrogen is from that 1 proton. So guess how many neutrons it has? 0. It has 0 neutrons. And the reason why is because this number is the number of protons, and protons also have mass, and so that's why this number is 1. Okay? Whereas this question here, what element am I? Well, this number down here is the atomic number, just like it is in the top one, the atomic number. And if you look on the periodic table, atomic number 1 is hydrogen, right? It is hydrogen. Okay, so let's even take this a little bit further. So the element is hydrogen, but how many protons does this element have? Well, it has 1. All right. How many neutrons does this guy have? Well, it has a mass number of 2, and one of those of those 2 mass numbers or mass units, I should say, one of them is a proton. The other one must be a neutron. Okay, so it has 1 neutron. Okay, so that's how these numbers kind of work. Again, keeping in mind, if I were to just take a look at like a proton or a neutron doing this kind of numbering scheme that we've been talking about, this 1 here means it has 1 proton and it has a +1 charge, okay, and the mass would be 1. Okay, if I had 2 protons here, the mass would be 2. If I had 3 protons here, the mass would be 3, and so forth. A neutron, oddly enough, has no charge. So notice this is 0 here. Okay, neutron, no charge. And this top number, remember neutrons do have mass though, and so it would be 1. All right. Now, electrons that we'll abbreviate that with an E, have a charge of -1, right? This is -1. But notice electrons have no mass. Well, they do have mass, but very little. They have almost no mass, and so this is now 0. Okay, and this all will hopefully make some sense as we go through and do some examples. But again, I think what might be useful here is to kind of look at this bottom number as the charge and this top number as the mass. I think that will be helpful for dealing with these nuclear physics problems. So let's talk about the type of particles that can be emitted from an atom. The first is called an alpha particle. And an alpha particle is really no different than just emitting a helium nucleus. And what can be found in a helium nucleus? Well, a helium nucleus contains 2 protons and if this number is 4 up here, 4 minus 2, it must contain 2 neutrons also. Okay, and the symbol for alpha is this kind of A-looking thing, or I don't know, sometimes it looks like a fish to me. Sometimes it'll be drawn like that. But basically, an alpha particle, if it's emitted, you're emitting 2 positive protons and 2 neutrons. That's what was being released if you have an alpha particle emitted. A beta particle is just basically an electron. All right, they just give a fancy name for an electron. Okay, so a beta particle is an electron. So remember, electron has no mass, and it has a charge of -1. That's its charge is -1. Now, a beta particle, it's written with this letter. It looks like a B to me, which is kind of nice, but the stick is a little bit longer, and basically it has no mass, and it has a -1 charge. Now, before we go any further, there is something called antimatter. And antimatter has the same mass, but opposite charge. Okay, same mass, but opposite charge. And so a positron is just the opposite of an electron. All right, and a positron, confusingly enough, is the same symbol as a beta particle. Now remember, antimatter has the same mass. So what mass does an electron have? 0. So a positron is going to have 0 mass. And opposite charge. Well, what charge does an electron have? -1. So guess what a positron will have? +1. Okay, and this is called a positron. So it still uses the same symbol as beta, but now it's just positive. So antimatter has opposite charges, and really the only one that we're going to be concerned with, like a proton has an opposite to it, but we won't really deal with it. The only one that you need to be familiar with is the positron, which basically is the opposite of an electron. Okay. The gamma particle is basically a high-frequency photon. It's solely energy, basically, is what it is. It's a release of energy. And the gamma symbol is this, I would call it kind of a Y, I guess. But notice, a gamma particle has no mass, and it has no charge. It's just basically a release of energy, and that's a gamma particle. Now, these particles are probably worth remembering. They'll be useful to help you with some of the example problems they'll do, and I will try to be very specific in terms of what you need to be able to do on the final exam. So, where is this all leading to? Well, there's elements in the periodic table that are called radioactive elements. And a radioactive element is basically a nucleus that is unstable, and it emits particles. It's shooting off particles until it finally becomes stable. So it's going to keep doing that. It's going to keep being radioactive until it's now stable. And radioactive elements can be dangerous because of these particles that are emitted. The particles emitted can cause harm to human tissue and just can cause problems. Now, we don't really go into the biological effects of radioactivity in this class, but just be aware that radioactive elements can be harmful to humans. So there's a couple different types of decays that you need to be familiar with. The first is called an alpha decay, and luckily enough, the name itself says a lot. Basically, it's an atom that is giving off an alpha particle. Okay, so here's my starting atom or element, and X is the symbol X is just it's the parent nucleus. It is the starting one. Now X, what does it produce? That's what this kind of arrow indicates. It produces a alpha particle, which is right here, plus the daughter nucleus, which is Y. Now, notice I have Z minus 2, A minus 4. Why? Well, the answer is because if I give off this, I am left with A minus 4 because I lost 4 mass units, and I lost a charge of positive 2. Okay, so I'm going to lose 2. So if I add this back up, if I take Z minus 2 plus 2, I get Z. And if I get A minus 4 plus 4, I get A. That is the big key for the final exam. They're going to ask you a question that's very, not exactly like this, but basically you need to figure out what particle would be emitted from an equation, and basically if you can make both sides of the equation be balanced, that's why I have this in big bold letters. Notice how both sides of the equation balance. If you can make it balanced, add them up, and they add up together, you're set. Okay? And it's a multiple choice question, and you basically need to be able to add up both sides of the equation. Now let's do some more practice problems with some of the other particles. This is called an alpha decay. Basically, it emits an alpha particle. This is called a beta decay, and as the name implies, basically it's releasing a beta particle. Remember, a beta particle is just an electron. That's a fancy name for basically an electron being released. So here is the parent nucleus, this X, and you have A and Z, A being the mass number, Z being the atomic number. And it produces a electron being emitted plus the daughter, okay, the daughter nucleus. So notice I have lost this electron that has no mass, lost an electron that has no mass. So I'll basically maybe plus A, because A plus 0 is A. And then I have Z plus 1. Why do I have Z plus 1? Well, because Z plus 1 minus 1 will equal Z. All right, so kind of just look at it like you're taking this side, and this side on the right must equal the parent nucleus. That is the big key. They have to add up to each other so that you keep things balanced. Because basically, what it all comes down to is that you can't just create or destroy matter out of nothing. It has to add up in some way, shape, or form. So this is called a beta decay. Basically, you're releasing a beta particle. This is called a positron emission. Again, you have the parent nucleus on the left, A and Z, and it produces a positron emission, which is just the opposite of an electron. It has a +1 charge, it has no mass, and so it produces a daughter nucleus. And notice instead of Z plus 1, now it's Z minus 1, okay, because you have to this has to counteract this right here. And then notice it's just A, because A plus 0 is A. Z minus 1 plus 1 is Z. So if you can just get these guys to add up again, basically to balance the equations, everything will be peachy. Now, this is the one scenario that's a little bit different. It's called an electron capture. Okay, and basically what it means is this atom is capturing or taking in an electron. All right, and so the electron is on the left side of the equation. Basically, you have this parent nucleus here, X with A and Z, plus the electron, which has a negative charge. Okay. And it's going to produce basically this, okay, this daughter nucleus over here. And again, notice how it balances. Z minus 1 has to produce Z minus 1, okay, and A plus 0 has to produce A. It's just, again, make sure they balance and everything will be okay. It's not so important that you understand, like, is it an alpha emission, a beta emission, an electron capture? That's not so much the important piece. It's being able to basically balance these equations is what's really important for the final exam. The last type of decay is called a gamma decay. Remember, a gamma particle is basically just a photon of light being emitted. And so here you have the parent nucleus. This little star here basically means the nucleus is in an excited state. And this is pre-emitting the gamma particle. So then it produces a gamma particle. This is basically just some energy that's being given off. Okay, notice it has no charge and it has no mass. And what are you left with? Well, here's the daughter nucleus, and notice it hasn't changed at all, right? It's still X and then AZ. The only thing that's different is there's no little asterisk here because it's no longer in the excited state per se. It's now released this gamma particle or photon, if you want to call it that, and now everything is balanced. Okay, so A plus 0 is A, Z plus 0 is Z. So let's just do some practice problems here. Here we have silicon with a mass number of 27, an atomic number of 14. Notice basically this guy now is aluminum. It's atomic number 13 and a mass number of 27. So these two haven't changed at all. So this particle that I'm going to put here, we'll call it Y. I'm pretty certain the top number is going to be 0 because 27 plus 0 will be 27. Now what can I put on the bottom here that would give me a 14 over here? 13 plus blank equals 14. Well, the answer is 1. Okay, and if I put a 1 there, then we'll be peachy. Well, by golly, what particle is 0 and plus 1? If we look back in our notes, this is called a positron. All right, and it isn't Y, it's actually a B with a long stick, I guess. I'm not real good at drawing these things, but it would look something like this, a positron. Okay, let's try another one. What particle is emitted in this decay? So here we have uranium with an atomic number of 92 and a mass number of 238, and it produces thorium with an atomic number of 90 and a mass number of 234. What particle would it produce, or emit, I should say? Well, notice 234 plus blank will equal 238. I'm thinking I have to put a 4 up here, right? That would give me 238. And 90 plus blank equals 92. What particle can I put, or what number do I have to put down here? 2, right? 4 and 2. Well, dang, if I look back at my notes, do I have anything that gives me 4 for a mass number and 2 for an atomic number? I think I do. I think that is called an alpha particle. And it looks something like this. This is just basically a helium nucleus has been emitted from this decay. Let's try one more. Here we have arsenic, and it has an atomic number of 33, a mass number of 74. It's producing selenium with a atomic number of 34, a mass number of 74. What particle would be emitted in this decay? Well, notice 74 plus blank equals 74. Well, I'm going to say 0. And 34 plus blank equals 33. Well, I think if I put a -1 here, I would then have things balanced. If I look back at my notes, what has no mass but has a -1 charge? Hopefully you're thinking an electron, also known as a beta particle. I wish I was better at drawing that, but a beta particle. And basically that is what you need to be able to do on the final exam. They're going to give you something kind of similar to this, and you need to just basically be able to balance the equation. And like I said, it's not so important that you remember beta particle, gamma particle, alpha particle, any of that kind of stuff. It's being able to do exactly this, balancing an equation. That takes care of this video. I will see you guys next time.